Hey, top paralyzed math and history, and we are going to graph the parabolas when b cannot become 0. In the past few videos, we have been learning how to graph the parabolas when b is equal to 0, but this time, what happens when b cannot equal to 0? Well, in the previous video, we've learned that adding a bx into the equation for quadratic standard form is going to make the parabola go off course, meaning it will go to another point on the graph, as if point of axis, or the line of axis, and the vertex. Because when we try to graph this quadratic trinomial, things are gonna be a little bit different, so buckle up and get ready to go. The first thing we gotta do is we're gonna ignore the y and the equal sign. So we can only focus on the 4x squared plus 8x minus 6. We are gonna look for the y-intercept, the vertex, understanding if it's up or down, and we're also going to look at the min/max. And finally, we're going to look at the number of x-intercepts. And we're going to find them out. So not only we're going to record these down, but also it's going to help us understand what our parabola will look like afterwards. So we're going to start solving. The first thing we gotta do is we have to find the vertex. But why are we not finding the y-intercept first? When we look at a parabola, the vertex happens when it is the point where the vertex or the parabola ends. So here's a parabola, and the vertex is where the point of where the curve ends. When we've been graphing when b does equal to 0, we have been looking at the y-intercept, and we can say that the y-intercept can be our vertex. But in this case scenario, when b cannot be 0, your y-intercept can never be your vertex. Your vertex will be on another point on the graph, but your y-intercept will still stay the same point, but it will not directly be the vertex. That's why we have to find the vertex first. When we do that, we can also find the y-intercept. But wait, how can we mathematically and algebraically find the vertex without visualizing it on a graph? Because we gotta graph it anyway. How do we do that? Well, there's a formula we're going to be looking at. Unfortunately, the formula doesn't really have a name because it's self-explanatory. The formula is x is going to equal negative b over 2 multiply your a value, which means that when you find x, when you do the math, you're only going to find your x value, like 1 for example. When you do that, you have to insert it back into the main expression and find your y value. That will become your vertex. So let's do a scenario. Since our negative b is going to be 8, we're going to turn that into a negative 8. If you have a negative 8x already, then you put it in with a negative b to turn into a positive. Because a negative times a negative is a positive. But since it's a positive and we're putting it into a negative times a positive, it will become a negative. So, negative 8, divide that by 2, multiply that, our a value is going to be 4. Because our a value equals 4, the coefficient in front of x squared, our b is going to be 8, and our c is going to be equal to negative 6. So, if a equals 4, we have to put it into a formula for right here. So bam! For this formula, for finding the vertex for the x value, we have to do the math now. So, we have to do order of operations. 2 multiplied by 4 is 8. So negative 8, divide that by 8. Since we have a negative being divided by a negative divided that by a positive will become a negative. That will be equal to negative 1, which means that our x value for our vertex is a negative 1. We have to insert negative 1 into the expression to find out what we get. When you do that, you get your y value. And when you do that, you get to smash that on the graph. Oh yeah, and don't forget to smash that subscribe button. So let's do the math. 4 multiply that by negative 1 squared plus 8 multiplied by negative 1 minus 6. So negative 1 times negative 1 is just a positive 1. Times 4 is 4. Plus 8 times negative 1 is a negative 8. Minus that by 6. So 4 minus 8 will become a negative 4. Minus that by negative 6, we're going to have an answer of negative 10. So, as negative 10 being our answer, when we insert negative 1 into the expression, we are going to put that there. So, our vertex, or the point where that curve ends, will become negative 1, negative 10. So, we're going to put that right here. Parentheses, negative 1, comma, negative 10. And we are going to put that on our graph. The first thing we do is the vertex. We are going to say that each square on the graph is equal to 1 unit. And when you show your math teacher, always label that this is 1 and 3 and other measurements like 4, 5. So we're going to use negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait. Negative 110 is right there. So after we do that, the second step is very simple. Now we get to go to the normal path, finding the Y-intercept. The Y-intercept is always going to become your C value. And it also has a point of 0, comma, something in a point for X and Y. In this case scenario, we have a Y-intercept of parentheses 0, comma, negative 6. When we do that, there's another point that will magically appear before our very own eyes, because when we graph that, we'll be able to use the line of axis.